Welcome to homework.
This is the answer to Chapter 14, problem number 31 from the Smith Organic Chemistry textbook. And in this problem, we're told that a compound of molecular formula C4H8O2 shows no IR peaks at 3600 to 3200 or 1700 wave numbers. And we're also told that there's one proton NMR signal and one carbon NMR signal for this molecule. And so given just that information, we're asked to determine the structure here. As I've said before, whenever we're given a molecular formula and asked to determine a structure, a good place to start is to calculate the hydrogen deficiency index. And so remember, that's going to be 2 times the number of carbons plus 2 minus the number of hydrogens. And then all of that is over 2. So in this case, it's 8 plus 2 is 10, minus 8 is 2, over 2 gives us an HDI of 1. And so we know that there's one ring or one double bond in this molecule. So then let's look at the other information that we're given and see exactly what that tells us. So the lack of an IR peak between 3200 and 3600 wave numbers tells us that there's no alcohol in this molecule because that's where we would expect the peak for an alcohol to show by IR. And the lack of a peak at about 1700 wave numbers tells us that there are no carbonyls in this molecule because, again, that's where we would expect a carbonyl peak to show. And so with no alcohols and no carbonyls, but 2 oxygens in this molecule, as per the molecular formula, we should be pretty sure that what we have are ethers. Then thinking about our other spectral information, there's only one proton peak. So all the protons here are going to be the same. They're going to be equivalent. And so likewise, there's only one carbon NMR signal. So all the carbons are also going to be equivalent. So we have all equivalent protons, all equivalent carbons, and we have 2 oxygens to account for with no alcohols and no carbonyls and 1 degree of unsaturation in this molecule. And so all of that information taken together means that there's really only one structure that we can come up with that satisfies this criteria. And so this is 1,4-dioxane. I've just drawn it there. All of the protons in this molecule are equivalent. All of the carbons in this molecule are equivalent. This fits our molecular formula. It fits our hydrogen deficiency index of 1 that we calculated. And obviously, there are no alcohols and no carbonyls here. And so this is the right answer. And again, the way that I arrived at this was to start by calculating an HDI and then considering the IR information that we were given that really tells us what we don't have. And then considering the fact that the single NMR peak for each of the proton and the carbon NMRs mean that all of the hydrogens are equivalent and all of the carbons are equivalent. And really, this is the only structure that we could come up with. And so that's the answer to Chapter 14, problem number 31.